Hey everyone, welcome back. We're in the next session of Shiny and R with three awesome speakers. Our first one is Nicole. She works as a bioinformatics engineer in the systems biology infrastructure team at Sage Bionetworks, a health research nonprofit. During business hours, she spends her time building software solutions that help researchers share their data in a way that makes it easy for others to find, learn about, download, and reuse. Nicole, take it away.
Hi, as already said, Sage Bionetworks is a health research nonprofit. We share data, expertise, and tools with researchers around the world to help them make reliable discoveries faster. Sage has dozens of projects in the works. Out of these projects, I'm most familiar with those represented in the AD Knowledge Portal, which is geared towards finding a treatment for Alzheimer's disease. Many different programs have contributed data to this portal to the tune of more than 25,000 specimens from 8,000 subjects, with more data coming in every month. It's a lot of data, and this is only one data set that we manage. Needless to say, we've needed ways to scale time-consuming tasks such as data curation. Many of our teams at Sage have turned to our Shiny for building these tools to scale up our work. Over time, we've learned a great deal about how to make these Shiny apps that I would consider contagious. These are the types of apps that are demoed during a meeting, and hands start clamoring for the keyboards or microphones to ask how they can use the app for their work as well. Today, I'm going to share with you some of the packages, tools, and other tips that we've learned in hopes that you will try some of them out when you design your next contagious Shiny app. My name is Nicole Kauer. I'm a bioinformatics engineer at Sage Bionetworks with a recent team change. To help set the stage for this talk, I will do a quick overview of the main apps that I've worked on, dccvalidator and its sister app, dccmonitor. So these apps are primarily for metadata validation. You can picture metadata as a set of data about an experiment with one row per specimen, containing all the information that's specific to that specimen. The problem is that it's really easy to make mistakes, and hand curating this data is unscalable. So let's take a really quick look at how these apps have helped the Data Coordination Center, or DCC for short, scale up their work. So instead of DCC curators checking data manually, DCC Validator puts the curation process back in the hands of contributors. They tell the app the study name associated with their metadata and a few other things. Then they upload their metadata to the app as 4 files that can be joined to create that full metadata set. Then they can click the validate button at the bottom and get a series of results. For anything that needs to be fixed, they get information on what that problem is. There's also a data summary tab, which gives an overview of the data submitted and can be used as a sanity check. So at the bottom, there's a couple of ways to see the data that's in the files. The first is this colorful way to see the data types and if anything's missing. We can get a deeper look by clicking on the Details tab, which shows a summary of each column that's in the table. So that's great. The contributors have a way to check the data themselves and fix any problems. But what if they run into issues? This is where dccmonitor comes in. It gives curators a way to check in on progress. All metadata is grouped by study name. The display section is long and wide, so I can't show it all. But this first part shows an overview of the files that were submitted, including the contributor's current validation score. At the bottom, there's the exact same features that are seen in DCC Validator, so that the curator can have access to all the same results and information that the contributor sees. And in the interest of time, I'm going to skip the extra features that are in these apps. These apps were initially created for groups contributing data for the AD Knowledge Portal, and they've been hugely successful for scaling up curation of that data. They've decreased the time needed to curate a single set of metadata from hours to minutes. These apps have also spread to others. Some groups are using customized versions of these apps, while others are using the underlying functions to help out with miscellaneous day-to-day curation tasks. In the development and maintenance of our Shiny apps, there's been 4 main points that I'd say have led them to being contagious. They are easily spreadable, which comes down to app organization, environment control, and documentation. They're adaptable because we design them to be. They're reliable because we add tests. And of course, they're desirable. We're going to use the DCC apps as a guide for discussing tools and tips for implementing these 4 ideas. Before we do, a quick note is that these letters spell sard, which is a type of brown-red quartz that can be made shiny. I collect rocks and minerals, and this is a shiny talk, so this acronym makes me very happy. So what do I mean by spreadable? Anyone who has dealt with sharing code, especially shiny apps, should have come across some of the less fun things about this process. Potential collaborators or users might not have the right version of R or the right packages, or maybe even the knowledge of how to run a shiny app at all. In short, what I mean by spreadable is that it should be as easy as possible to get and get running. So let's look at some ways that this can be simpler. I'm sure many of you have probably heard of the Golem framework for shiny apps. There's enough of this framework to literally fill a book, which is linked here. The main benefit of this framework is the idea of creating the app like any other R package, which then opens your app to the wide world of package tools. Many of the tips here all build on this framework. dccvalidator is an R package, and its codebase looks like one. Throughout this talk, I'll emphasize any codebase additions from these tools as orange in this structure. The package is on CRAN, so I can use the traditional install packages to get it on a machine, load the library, and run the app. When I'm developing the app, I can use the handy DevTools load all to get my local development version of the package loaded at once and test out the new features I'm building. This works with collaborators who want to use the app as well. The code's on GitHub, they can clone the repo to their local machine, make any alterations they need, load the library, and run their own version of the app. Keeping the app in a package format helps keep the code organized and easier for contributors to locate what they're looking for within it. As a package in general is easier to pass to someone than a bunch of seemingly random files that have to be used in specific ways or sourced directly. Using this Golem framework idea of packaging up your shiny apps will help increase their ability to spread to others. Of course, wrapping up your app in an R package doesn't necessarily help with the differences in package dependencies between one machine and another, or even on your own machine from one moment to another. While Golem makes your app easy to install, it doesn't keep the same versions of packages with your app. And having your app break immediately on install is the opposite of a spreadable app. No one will want to deal with the hassle of figuring out why your package isn't working for them. RM is used for package management, and it's a great way to control your app's dependencies, which is especially important for development with collaborators and launching the app on a server. Locally, RM will create a new folder for your package dependencies and set out their specific versions in an RM block file. We use this in our apps to control package versioning, and it makes firing up a new version of the application on our server super simple, and better yet, we know it will work. What I like so much about RM is that it's super simple to set up and use. There's 3 main functions, and it will take stock of what your app's using and do the initial setup process. After you add or upgrade a package, you can just use the snapshot function to capture your latest development environment. And if you need to reset your environment or you're developing on a new system, use restore to get your app's personal library up to date with where it should be. While it takes some time to get used to using a package manager like RM, it makes it easier for someone to choose to collaborate or even to use your app at all when they don't have to deal with the minute details of package versions. Easily spreadable apps also have good, thorough documentation. For documentation, dccvalidator has a docs site hosted by GitHub Pages, vignettes specific to the package, as well as imported into the app, a README with general information, and more. While Roxygen 2 won't write your function documentation for you, it can help keep the namespace file and man pages current for the functions that you have added documentation to. And using this existing documentation, Package Down will create a website to better surface this information. My favorite part of the Package Down sites, as we've seen earlier, is this reference guide, which lists all of the exported functions in a clean, skimmable way. The package Use This has a handy function to also help quickly create and push your website to GitHub Pages. And there are GitHub actions that will automatically update and relaunch your docs site when needed. It's hard to know what an app is or what it's used for or why I would want to use it if there's no documentation. Documentation spreads the message about what your app is and why someone should take advantage of it. For a Shiny app to be contagious, it should also be adaptable. While the purpose of an app may be useful to many groups, it's doubtful that they all want or need exactly the same app, even if the difference is simply changing from one logo to another. It's really the functionality that they want, but everything surrounding that functionality should adapt to fit their needs. One way to make an app adaptable is to take advantage of Shiny modules. Modules are like plug-and-play mini chunks of your app that you can use once or over and over. dccvalidator has many modules, and we already saw some of them earlier. There's 3 modules on a tab I haven't shown, including one for the entire tab, and one for entering the study name, which is also used on this validation tab. The entire tab section is a module, as are the results boxes and the data summary features. Designing your app to be modular will make it more adaptable for others. It's quite possible that they even have their own app and just want a piece of yours. If that piece is a module, it's much easier to port into their app. In fact, dccmonitor uses some of the modules from dccvalidator. A configuration file on top of modules can help make your app take your app to the next level of adaptability. The best thing about a config file is that you can have multiple versions of your app running, and the only thing you have to change is what configurations you're pulling in at startup. When combined with modules, it can be really, really powerful. In dccvalidator, I was recently asked to remove a feature that was no longer needed for a group. Because the feature was already modular, instead of having to remove it for everyone who wanted to use the app, it only took about 15 minutes to make the feature customizable via the config file. Now, anyone who wants to use the app can choose whether they want that feature or not by simply turning it on or off in the config. Not only does design with a config file make the app easier to adapt, it's proven vital to the success of our apps. It's also really hard to get excited about using an app and adopting it if it's buggy. It just really is. Designing your app with reliability in mind can help with adoption. So adding tests for functions is incredibly time-consuming, but completely worth it. While sometimes it can be tedious, especially when I need something done yesterday, it's nice to be fairly confident that the code I'm writing is doing what I expect it to and nothing else. TestStat is a package that many of you have probably heard of. It works great for unit testing package functions. There's some packages for Shiny testing, but given the challenges of testing user interfaces, I haven't found one that I enjoy using yet. For now, whether you do have a Shiny testing package you like or not, I recommend breaking out anything that doesn't absolutely have to be in a Shiny UI or server function into its own function, or better yet, a set of functions that can be tested with TestStat. However, for those of you who are familiar with Shiny reactives and trying to pass them to a non-Shiny function, I'm sure you know it can be challenging and frustrating when you make a mistake and don't unwrap your data from the reactive. When developing a new function, you can add a stop if not test at the start to make sure you're passing the right variable. This can save time by helping you figure out if the problem is coming from the Shiny side or the new function you're creating. I haven't done this yet in dccvalidator since it's something new I've learned, but I've been using it for spot testing and it's a huge time saver. The main point is that designing your app to be reliable by adding in testing will save everyone, both yourself and potential adopters, from a headache later on. And of course, contagious apps are desirable apps. The good news is that coming up with an app that would be desirable to multiple people is technically the simplest part. Everything else I've mentioned takes thought, planning, and good old-fashioned elbow grease to do, but this just involves some daydreaming. There's a lot of Shiny apps out there. Many apps are really cool and fun, but the question is, what sets the contagious apps apart? From my experience, it's the practical apps that are contagious. These are the apps that take tedious or repetitive tasks and make them doable with the click of a button. This is what makes dccvalidator and dccmonitor so contagious. They decrease the amount of time needed for data curation, and they do so by wrapping up many time-consuming tasks into a simple interface. Any task that takes a lot of time and has a visual element is potentially a good candidate for an app. They don't have to be flashy or nice looking either. I built dccmonitor when I was an intern at Sage, and it's not the prettiest app out there, but it's useful, and that's really the important part. So to sum up, to design a contagious app, design it around a problem or a set of problems to make it desirable. Maybe you've already done some of the hard work and have a set of functions you've developed. See if there's a way to incorporate them into a one-stop, click-and-be-done action. Make those functions reliable with testing and adaptable to similar but slightly different use cases. Then start building a simple Shiny interface around them, following the Golem framework idea of making a package, complete with documentation and package management. Finally, I want to acknowledge the creators and collaborators on these two apps, as well as thank the Sage Bionetworks team and Our Ladies group for the practice talks and great feedback. And you can find these slides in my GitHub.